This is Biological Transitions, Part 3, and this is called Onset of Puberty. So what does all of this that we've been talking about with the endocrine glands, what does all of this even have to do with puberty? Well, puberty begins when there's genetic and environmental signals that then instruct the hypothalamus to change the set point. And if you're curious, what are those signals that tell the hypothalamus to change the set point? Well, it's a great question. Mainly, those signals are coming from a neuron called kisspeptin. Your book was quick to point out that kisspeptin is named such because it was kind of discovered or named in Hershey, Pennsylvania, where the Hershey Kiss is from. So kisspeptin is what we have. Kisspeptin neurons regulate the mechanisms that determine the timing of puberty, like the onset of puberty, right? Puberty is stimulated when these kisspeptin neurons increase in the body. So kisspeptin is affected by leptin, which leptin is this hormone in the body that helps your body kind of maintain its weight. It kind of helps this set point of weight, if you will. And an increase in leptin means an increase in kisspeptin and an increase in body fat percentage as well. Leptin kind of acts as this suppressing agent for fat. So the more weight that you gain, the more leptin the body will produce to try to suppress your appetite until your weight is lost in order to maintain your set point or homeostasis. Although we're talking about an increase in leptin at the onset of puberty, it then tends to kind of decline thereafter. Kisspeptin is also affected by melatonin. Now, you might recognize melatonin because melatonin is our sleep hormone. Melatonin is a hormone that's levels kind of rise and fall based on the amount of light that our retina is receiving. If you've had me in Psychology 281, you've heard this story in our consciousness module. The retina signals to this very special part in our hypothalamus called the suprachiasmatic nucleus. And this little tiny part of our hypothalamus is light sensitive. So the retina signals to the suprachiasmatic nucleus, and the signal then gets sent to the pineal gland. So that part of the hypothalamus says, hey, pineal gland, you need to either start or stop producing melatonin based on the amount of light. So if this is kind of happening, like let's say there's a whole bunch of light coming in, then what's happening to your melatonin is that it's decreasing and you don't feel sleepy. All this amount of light makes you not feel sleepy because all that melatonin has kind of gone away. As it gets darker and your retina is not sensing light anymore, that suprachiasmatic nucleus sends that message to the pineal gland of, hey, it's time to secrete some melatonin. And then the pineal gland says, aye, aye, sir, like, let's go, let's produce this melatonin. And then the melatonin gets produced and then you start to feel sleepy. So all of this basically regulates your sleep patterns. And what does this have to do with kisspeptin? Well, kisspeptin levels vary depending on the level of melatonin in the blood concentrate. Generally, melatonin is known to suppress kisspeptin. It's unknown exactly how, but studies have found that an increase in the use of a synthetic melatonin, so like you take a melatonin gummy or a supplement to help you sleep, like you're using it as a sleep aid, it could actually delay puberty. So if children are taking these synthetic melatonin, it could actually delay the onset of puberty if they're having an increase. Why? Because it's messing with the levels of kisspeptin, right? Genetics also plays a really big role in the onset of puberty in addition to the levels of kisspeptin in the body. Genetics predispose a person to go through puberty at a certain age, but I don't want you to think that it's like a set age. It's more of like an age range, okay? Environment also plays a role. If the person's eating in excess and has high body fat percentage, that could increase the leptin because your body's trying to regulate the level of fat and maintain that homeostasis. So the increased leptin in the body happens, and then the increase in leptin could trigger the increase in kisspeptin, which could increase the onset of puberty or start puberty. If the person has a significant amount of light exposure, even artificial light like blue light from screens, or maybe they live close to the equator or something like that where there's a lot of light all the time, then they will have consistently lower levels of melatonin, which will not suppress the kisspeptin production, and therefore puberty could actually come on earlier. So the environment plays a really big role as well. And that's going to conclude this video.